Hello everyone, my name is Yao Meng, one of the authors of the paper. I'm honored to have this opportunity to share our work with you. In the field of computer vision, event-based dynamic vision sensors are transforming the landscape with their high temporal resolution and low power consumption. When combined with sparking neural networks, these sensors offer a promising solution for energy-efficient and faster reacting version system. From the figure, you can see the entire process from the acquisition of DVS data to the final output. Recent studies have shown that most adversarial attacks on SNN target grid-based representation of data, often referred to as frames. It can be divided into the binary input and the real value input setting. While this approach simplifies the optimization process by reducing the optimization space, it also introduces some limitations. First one, grid-based representation served as the intermediate stage between raw event data and the SNN processing pipeline. If a model only accepts raw event data, this attack method becomes ineffective. Number two, even when frames are used to simulate original event data, there is still a significant discrepancy, especially since events indices information is lost during the attack. So, what if we take it a step further and directly attack on the raw event data? This is the primary focus of our study. As shown in the figure, the difference between ours and the existing methods is clear. Our attack method avoids the issue associated with grid-based approaches. Compared to the traditional methods, our modifications to the original event state are minimal. For instance, a change in a frame's value could result from thousands of timestamp changes, while our approach preserved more of the original event characteristic. Our core technique is reparameterization using a concrete distribution. Specifically, we employ the straight-through Gumbel softmax. In an automatic differentiation framework, we need to separate the sampling process from the network operations to ensure that can be optimized. The Gumbel softmax approach meets these requirements. It preserves the original probability distribution while remaining differentiable. Here is a brief overview of our approach. We start with the original event stream and separate the indices and the polarity information. A three-dimensional date structure is used to represent positive and negative polarities, where 001 for positive, 100 for negative, 010 for no event. Then we use Gumbel softmax sampling to obtain the soft value, which allows polarity change during the sampling process, just like this polarity. These soft values are then converted back to binary data using argmax and one-hot encoding, accumulating several frames over a time window. This process is fully differentiable, enabling us to directly compute the gradient of the loss concerning alpha. Given the change of attacking only existing events, we also consider adding new indices in the x, y, and t dimensions. In our experiments, different methods of adding additional coordinate information were explored, and this addition significantly improved the attack success rate. Our empirical results demonstrate that our approach achieves significantly higher success rate in targeted attack compared to the conditional methods. Our method not only preserves the sparsity of data, but also enhances attack performance. In conclusion, our study breaks new ground by demonstrating the feasibility and the effectiveness of direct adversarial attacks on raw event data in SNN. Thank you for your attention. Stay tuned for more insights into cutting edge of neural network research.